Lesson 8.1.12, Puzzling It Out, Proving the Triangle Sum Theorem. In this lesson, we'll explain using pictures why the sum of the angles in any triangle is 180 degrees. So let's get started with the notes, but we actually have two things I want to hit today. I want to take a look at these notes to prove why the angles in a triangle are 180 degrees. But I also want to work on a little note card to help you prepare for the unit test that goes through the angle measure tools that we have. Go ahead and start with these notes. So our goal in this lesson is to use pictures to explain why the sum of the angles in a triangle, to explain why the sum of the angles in a triangle equal 180 degrees. That's any flat triangle that sits on a plane. And the way we can do it, the way we can prove that this will work, besides just using patty paper and tearing up the angle sides the angles like we did in the last lesson, we can use parallel lines and angle relationships. We understand why the angles in a triangle always add to 180 if we take a look here. Here is triangle ABC. You can see it here. In fact, I am going to just highlight a little bit here. This triangle. You'll see why I'm highlighting in different colors here in just a moment. And I'll track here a little bit. So there's triangle ABC. Now I know it's that because it's a triangle, this angle plus angle Y should all add up to 180 degrees. We're going to take a look at a parallel line, a line that's parallel to AC down here. Line DE is parallel to AC. I can see that they're parallel because they both have those little arrowheads there. And it contains point B. And we're asked to label the missing angles using X, Y, or Z to show which angles have the same measures. So we're asked to find the measure of angle A. Well, let's remember that these two lines at the top and bottom are parallel. And we have this pink transversal line. And with that pink transversal line, I'm going to just highlight the two angles that make up angle X. A few lessons ago, we talked about how we could find other angles between these two parallel lines that had the same measure as X. And I just want to remind you that I could just take some patty paper here. And if I were to rotate angle X at this point, it would land right on top of angle A because these are parallel lines. So angle X and angle A here have the same measure. So I'm going to go ahead and label it with the same letter. This angle is X degrees, and angle A down here is X degrees. And we could do the same thing with angle Z. If I look at the two lines, or the two rays that make up angle Z, I could take angle Z and rotate it as well. All right, there's angle Z right now. I lined this up earlier. I think this is my center of rotation, and you'll see that when I turn this, angle of rotation was a little bit off, but it's the same as this angle down here, that other angle in the triangle. Since they're the same measure, I'm going to call this angle Z as well. So we figured out the measure of angle A and the measure of angle C. So how does this diagram show that the angles in a triangle add up to 180 degrees? Well, if we look at these three angles up here, we know that they need to add together to be 180 degrees because they form a straight angle. And since x plus y plus z is 180 degrees, I can say the same of the same variables in my triangle. X plus y plus z still has to equal 180 degrees, just like it did in the straight angle at the top. So Let's just try and put that into words a little better. How does this diagram show that the angles in a triangle add up to 180 degrees? Well, we know that x plus y plus z equals 180 degrees because it forms a straight angle. So when we add up those same things, x and y and z, in the triangle, it should equal the same thing. Oops, it's supposed to be a little bracket. So x plus y plus z in the triangle must, equal 180 also. So this x plus y plus z was from the straight angle. So that's just one more proof of the fact that in a triangle, the three angles add together to be 180 degrees. So I just wanted to hit that little fact again with triangles, but I also want to get you prepared for the Unit 1 test by looking at these last three lessons where we've talked a lot about angle measure tools. Now, some of these are from last year when you were in 7th grade, but I wanted to talk about these first. Complementary angles are angles that add up to 90 degrees. So I can see that this angle and this angle form a right angle or a 90-degree angle. So to find that missing angle, or a pen here, if I take 90 and I subtract the angle I know, then that'll give me the remaining part of that 90 degrees. Because I know they add together to equal 90. Supplementary angles are kind of the same way. I know that these two angles have to add up to 180 degrees. So if I take 180 and I subtract the angle I do know, this 40 degrees, that leaves me with the rest of the measure. So in both of these, if I know what the two angles add up to, I can start with that, subtract off what I know, and I'll be left with the remaining part of that angle. What we started in this unit was vertical angles. Remember that vertical angles are formed by intersecting lines, and they're on opposite sides of this X that the intersecting lines form. And vertical angles always have the same measure. We can use rotation to rotate that 25 degrees over to this side right here. So if you know one vertical angle, you know the other one. As long as I'm here, I'm going to go ahead and combine this with supplementary angles to find these other two measures. There's a couple of different ways we can look at this, but let's just imagine this straight angle here. I know that they should add together to be 180 degrees. And if I take 180 and subtract 25, that leaves me with 155. And I can go ahead and say that this is 155 as well, because these are vertical angles. So vertical angles are always the same measure, and they appear on opposite sides of an X. We looked at parallel lines. We can tell things are parallel if they have these little arrowheads. And if they're parallel, then we can use a lot of transformations, starting with, if I know this is 45 degrees, I can translate it right down here to say that this is 45 degrees. You can combine this with what we know about vertical angles. With our original 45-degree angle, we know that this angle is also 45 degrees. And we could take that and translate it right down the transversal line. And that angle is 45 degrees as well. So there's 4 angles that are 45 degrees. Once again, I'm going to go ahead and continue with this by determining what this angle is. I have a straight angle here. This is 145 degrees. So if I take 180 and subtract this, I'm left with 135. Well, once I know that this is 135, I can do the same thing that I did with the 45-degree angles. I know that 135 has a vertical angle, and both of these can just translate right down to this other parallel line, and we can fill in these last 2 angle measures. So given just one angle measure in parallel lines, I can find 7 others. And to finish up, the last tool that we've been talking about for a couple of days is the fact that triangles always add up to 180. If you want to find the third angle, add these two and then subtract from 180. 85 plus 55 gives me 140. Oops, it's kind of small. And then if I subtract that from 180, I'll be left with this third angle. So these are the 5 tools that you have dealing with angle measures. And you can still use that note card from the previous quiz on the unit test as well. So good luck with this final homework assignment on lesson 12 tonight, and you might consider making your own note card to use on the test.